Calculate the elastic strain energy per unit volume for example 2, the previous example. To calculate the elastic strain energy per unit volume, we need to multiply the stress in each direction times the corresponding strain in the same direction. And so I've written down the stress matrix that we were given in the last problem, as well as the strains that we calculated. And to get the strain energy per unit volume, we need the equation for the strain energy per unit volume. And I'm just going to write that out in general terms. It's equal to 1/2, and here we're going to have a whole series of terms that correspond to the stress and strain in each direction. So the first term is sigma x times epsilon x plus sigma y times epsilon y, the second term, and then so on, sigma z, epsilon z. And then we have the shear stresses and the shear strains, sigma yz, gamma yz, plus sigma xz, gamma xz, plus sigma xy, gamma xy. Okay? So that's the general expression. And in our problem, sigma yz and sigma xz are both 0. So this guy here is going to be 0 for us, and that guy there is going to be 0 for us because the stresses are 0. So then to calculate this, we just need to substitute the values in from the two matrices, and so that I don't have to keep multiplying factors of 10 to the 6 and 10 to the minus 4 for every term. I'm going to pull those out and leave them at the very end of this equation. So I'm going to have 1/2, sigma x is 75, epsilon x is 2.22, plus sigma y is 50, and epsilon y is 1.21, plus sigma z is minus 10, and epsilon z is minus 1.21. And then sigma xy is going to be 20, and the strain gamma xy, the shear strain, is going to be 1.61. And now I need to multiply that whole thing by 10 to the 6 to get it in newtons per meter squared. And then I need to also multiply times 10 to the minus 4, because all of the strains are multiplied by 10 to the minus 4. Okay? So then if I calculate that whole thing, I get 136 times 10 to the 6 times 10 to the minus 4, and my units here are newtons per meter squared, and I can multiply that by meters over meters, and that's going to give me joules. Newtons per meters is joules per unit volume, meters cubed. So if I just write that a little more neatly, I get 1.36 by 10 to the 4 joules per meter cubed, and that's my answer. That's the end of example 3.